let's get ready for the test on Unit 7 by taking a look at the practice test here. So it says show all your work and thinking for each problem and be sure to circle your answers. So let's take a look at number 1. It says in a group of 154 students, 4 out of 7 like math more than English. How many students in this group like English? Okay, so the first thing we've got to notice here is 4 out of 7. This right here is a part and that's the whole. So we're going to do, let's see, we've got math and we've got English, and then we've got the whole, or we've got the total here. So this is going to be 4 out of 7, so that means the ratio here would be 4 to 3. And then it says there's a group of 154 altogether. So what we need to realize is this is all the students all together. If we added them all up, like we do 4 plus 3 equals 7, we're going to have to add the two of these actual numbers, the larger numbers of students, and we're going to get 154. So what that's going to do is that's going to allow us to figure out what the scale factor is here. So we're going to take 154, we're going to divide it by 7. I'm going to grab the calculator. 154, and we're going to divide by 7, and we end up with 22. So that means the scale factor here is 22. So we're going to multiply by 22. So if we take 3 and multiply by 22, we're going to get 66. And if we take 4 and multiply by 22, we're going to get 88. So again, just to double check those, always a good idea. So if I do 4 times 22, we end up with 88, and 3 times 22, we end up with 66. And if we add the two of those together, let's do 88 plus 66. This is our double check. We did end up with 54. So it says how many in this group like English? So the answer on that one is 66 students like English. So we're going to write 66 students like English. Oops, I guess I ought to capitalize that, right? So English. Okay, so we'll go ahead and circle that right there, and then we'll take a look at the next one. Danny has $248 in a savings account. The ratio of his savings to Jill's savings is 8 to 6. How much does Jill have in savings? Okay, so let's see. Here's what we've got here. We've got Danny, and we've got Jill, and it says his ratio to her is let's see, 8 to 6. So we're going to do 8 to 6, and it says Danny has $248 in his savings account. So on this one, we don't need to worry about the whole here. It says he's got $248 in his savings account, and what we're missing is that number right there. So again, there are a couple different ways to do this. I'm going to do both. I'm going to solve this using a scale factor, and I'm also going to solve this using the cross multiplication. So I'm going to take 248, and we're going to divide by 8. So we end up with, let's see what we've got here, 248 divided by 8. And we've got 31, so that's 31. So there's our scale factor. I could have put a box around that right there, and times by 31 here, we'll put a box around that. So if we multiply by 31, so this is going to be, let's see what we have here. So this is going to be 6 times 31, and we end up with 186. So I'm going to go ahead and put that number as 186. So she must have $186 in her account. So I'm going to write Jill has $186. Okay, so we'll go ahead and circle that. Now there are a couple things that you might notice. If we were to go ahead and do this problem this way, let's do 8x equals 6 times 248. You'll notice something when we solve this, that we end up with this 248 divided by 8, same thing we had here. So this is going to be 6 times 31. We're going to get the same answer. You might also notice that it's possible to go ahead and reduce this. This also is 4/3, just like the other one was 4/3. So if we wanted to solve this proportion, that would work also, but any way you want to do that is fine as long as you're showing your work for that. So let me slide down here. We'll take a look at the next couple of problems. It says solve each proportion, round to the nearest hundredth if necessary. So remember, if there's decimals in the problem, we're going to answer as a decimal. Otherwise we're going to answer as an integer or as a fraction. So let's go ahead and do this one. I'm going to do cross multiplying here. So this is 10x, and on this one, because this is such a small number, I'm going to go ahead and do 8 times 5 is 40. Let me write that first though, just to make sure we're all on the same page here. So 5 times 8, This would be 10x equals 40. We're just going to divide by 10, so we're going to end up with x equals 4. So there's, 4. So there's the answer on that one. Let's take a look at this next one here. I am going to leave this in this unmultiplied form, in this factored form, if you want to call it that. We'll just leave it the 18 times the 21. We're going to divide by 14 here, and then let's see what we can come up with. I'm going to change colors here so we can cross cancel. Let's do 7 goes in here twice, 7 goes in here 3 times, and then we can cross cancel here also. So this is going to be 2 goes in here once, 2 goes in here 9 times. So when we multiply the two of these together, we end up with 27. So the answer on this one is, whoops, let me change colors again. Answer on this one is 27. So we'll go ahead and circle that. Okay, this next one's a little more interesting because we've got a variable on the top and a variable on the bottom, and this one is a binomial. So you remember we want to group those together, so we're going to put those in parentheses, and then we're going to multiply here and here, and these are fairly large numbers, so I'm going to make sure that I write everything out, and then we'll make sure that we use a calculator to get the correct answer here. So when I distribute through here, we get 15x, and then we've got 15 times negative 12. So I'm going to do 15 times 12, and that's going to give me 180. Now don't forget this minus right here. So this is minus 180 equals 12x. And then we'll go ahead and we'll solve this. So I'm going to blow this up so we can get a little bit closer look at it. We are going to subtract 15x here. Now I know normally we'd move the smallest one, but if we did that, we'd have to move the 12x over here and the 180 on the other side. We can deal with a negative coefficient here. It ends up being negative 3x. So 12x minus 15x is negative 3x. And then all we have to do is divide both sides by negative 3. So we're going to end up with x equals, and then a negative divided by a negative, and we could do a little bit of cross cancellation. If you want to double check on the calculator, this is going to work out really well. So this is going to be 180 divided by 3. It's kind of like 18 divided by 3, and then we just add that 0 on there. So we end up with a 60 on this one. So we'll circle that, then we'll slide over here and take a look at these other guys. Alright, so let's multiply here. So this is going to be 15x, and then this is going to be 5 times 46. Again, we'll divide by that 15, and then we keep in mind we can do some cross cancellation here. I'm going to cross cancel 5 with the 15. That ends up being a 3, and then you'll notice that what's left here, we've got a 46 on the top and a 3 on the bottom. 46 factors to a 2 and a 23, nothing in common with the 3, so this is going to be 46 over 3, and the nice part is we just get to leave that. We'll take a look at this one here. Again, we're multiplying here. That's a binomial, so I'm going to go ahead and put that in parentheses. So that's going to be k plus 2. And then on this side, we get a 3 times a 26. So this is 8k and then plus 16. And I'm going to grab my calculator for this. I think I know what that is, but we're going to do 3 times 26. I think we get 78. We do. So that's, 78. Make sure we write that down the right way, and then we're going to subtract 16, so we get 8k is equal to, and then 78 minus 16, if you want to double check on your calculator, that's going to be 62. So we're going to divide by 8. Now 8 does not go into 62 evenly, so we stop thinking of this as a division problem and we start thinking of it as a fraction. So they're both even, so 2 goes in here 31 times, so I'm going to write 31 on the top, and then 2 goes in there 4 times, and that definitely does not reduce anymore, so we're done with that problem. And then this last one here, we've got a bit of a mess on our hands because we've got some decimals in here and a binomial and a variable on the bottom. So we're going to multiply here and we're going to multiply here. So here's what we've got: 2.4 times n minus 0.4. And then on this side we have 2.28n, and we're going to multiply that by 6. So let's see what we get here. That one's not too bad. 2.4n. And then minus, I know that is going to be negative, so we'll grab the calculator for this one. 2.4 times 0.4. Let's see, yep, we got that. And so this is going to be negative 0.96. And then on the other side, let's see what we get out of this. We get 2.28 times 6. Always a good idea to make sure you've typed it in the calculator the right way. we get 13.68. So 13.68, and we've got an n on there. Same thing that happened up above. Let's go ahead and move this one. It does happen to be the smaller one in this case. So we're going to subtract 2.4n. Now I'm going to rely on the calculator to get this right because this is a pretty ugly decimal. We could probably try and do something like that in our head, but let's make sure we get it right. So 13.68 happens to be the last number here, so I just want to hit subtract the 2.4. Now we're expecting something in the 11 range because I've got 13 point something minus 2 point something, so it should be, looks like 11.28. So 11.28. Notice that it is positive because the bigger one is positive, and then we're going to divide both sides by 11.28, and there's no way I'd want to do this one by hand. So let's go ahead and get rid of that. We've got an n over here, and then we grab the calculator on this one. So I'm going to go ahead and do negative 0.96, and we're going to divide that by 11.28. So it looks like we've got everything typed in there the right way. So here's what we've got, negative 0.085. So negative 0.085. Well, we're going to write that. We want to round to the nearest hundredth, so that's going to be negative point. This is either going to be 0.08 or 0.09, and that 5 is big enough to bump it up, so this is going to be 0.09. Let me make that 0 look just a little bit better right there. Anyway, that's our answer on that one. So now let's take a look at the ones at the bottom of this page here. And the instructions on this one say circle proportional or not proportional for each of the following and explain why your answer is correct. So let's take a look at number 9 right here. So we went over a couple of things in class. If we're looking at a graph, it's pretty easy to tell. It's got to be a straight line, which both of these are, but it's also got to go through the origin. It's got to go through 0, 0. So this one is a straight line, and it goes through 0, 0. So this one is proportional. So we're going to say a reason straight line and goes through 0, 0. Okay, and the next one, this is a straight line, but it doesn't go through 0, 0. So we're just going to say not proportional, and we're just going to say doesn't go through the origin. So I'm going to say origin right here. Remember, origin is another way of saying 0, 0. So I'll just put that on there just to make sure we're all clear on that. And then let's take a look at the next one. Now remember, if we've got some data, if we've got some points, if we've got a table, if we've got some numeric information, the way we check to see if it's proportional is we check every one of the x over y ratios. Remember, we do with this kind of counterclockwise rotation. We put the y on the top and the x on the bottom. That's just kind of convention. So and 0, 0 isn't included in that. We can write an NA on that guy right there. So if I do negative 3 over negative 1, if I do the y over the x, I end up with 3. As long as the rest of them are 3's, then we're in good shape. It would be proportional. But let's take a look at this one right here. If I do 6 over 3, I end up with a 2. Okay, so that's not proportional. So what we're going to say on this one is not same rate. We could also say this, not equivalent ratios. Not equivalent ratios. Okay, so let's take a look at this next one. Let's do 10 over negative 2. We end up with negative 5. Okay, so they all need to end up being negative 5. So let's check this one. This would be 5 over negative 1. That would be negative 5. And let's just kind of eyeball a couple of these. Negative 15 divided by negative 3, that would be negative 5. I'll write this one down. Negative 20 over 4, that would be negative 5. Whoops, negative 5. And this last one, negative 50 over 10, that would be negative 5. So they're all the same proportion. So we're going to write proportion, and we're going to write all same ratio. And instead of saying the same ratio, what we could do is we could say equivalent. So again, up here I'm going to write equivalent. All equivalent ratios. Okay. All right, let's take a look down here at the bottom. Now, when we get to an equation, so when we get to an algebraic representation of what goes on here, every single time we ended up with y equals the unit rate times x. So I'm going to go ahead and put that unit rate in parentheses. So what it looked like most of the time is we used a kind of a letter for this. We said it's y equals kx. So it's kind of like a constant rate. It's the same rate all the time like we had up here. So if it fits this form, then it's proportional. If it doesn't fit this form, then it's not proportional. So we can't have any addition or subtraction. All it is just multiplication, and if you wanted to think about it this way, it would be division. So we could also come up here and we could say that's got to be a constant like that. So that's another interesting way to kind of tie all these together. So let's take a look at this right here. This one is not proportional because it's not y equals kx. It doesn't fit that format. This one over here, this one is proportional because it's y equals kx. The constant on this one happens to be -4. Okay, so this one is not that, and this one fits that same form. It fits y equals kx. All right, we have this story problem. And I think we've talked about Joey Jaws Chestnut before. He's an eating contest guy that goes all over the country winning eating contests. And I think this is actual data. I think this is from one of his Nathan's Hot Dogs eating contests. So you'll notice that this problem has several different parts. So I'm going to leave it right here. And let's fill out what we've got right here. So it says Joey Jaws Chestnut, the famed king of eating contests, can eat 66 hot dogs in 11 minutes. And I believe that's pretty darn accurate. Complete the table to show the relationship between minutes and hot dogs. Okay, and then it says think about how to label the columns in the table and the axes on the graph before you start. So we've got to give this some thought. So should we do, now remember it's going to be the y over the x, should we do hot dogs per minute or should we do minutes per hot dog? Well, it probably makes more sense to do hot dogs on the top and minutes on the bottom. Remember, this is like the y and this is like the x. So that means x is going to be like the minutes. So we're going to do minutes here and we're going to do hot dogs here. And just as a reminder, I'm going to put x and y there, so just so we can remember. And while we're at it, while we're labeling, let's come over here and let's put minutes here and let's put hot dogs here. Now the scaling we'll figure out in just a second. We'll do that when we get there. But so let's start off with 0 minutes and 1 minute, 2, 3, 4, and so forth. Now if he can eat 66 hot dogs in 11 minutes, 66 hot dogs in 11 minutes. That means it's 6 hot dogs per minute. So let's run through and fill this out. 0 minutes. Okay, before they start, he wouldn't have eaten any hot dogs. In 1 minute, 6 hot dogs. 2 minutes, 12 hot dogs. 3 minutes, 18 hot dogs. 4 minutes, 24 hot dogs. I mean, gosh, if you stop and think about that, that's just incredible. Okay, and then we're going to go ahead and we're going to graph this. So we've completed the table and we've shown this relationship. And then it says graph the data from the table to show the relationship between minutes and hot dogs. Okay, so let's come over here and let's think about this. We only have to go up to 11 minutes, but we've got to fit 66 hot dogs on here. So let's do this. This would be 2, 4, 6, 8, 10. Let's just do that. Let's do, this is 1, 2, 3, 4. We'll just count by ones. Okay, 11 minutes is what we had there. And then I suppose we could try and fit this on here. I mean, we don't absolutely have to, but if we're going to fit 66 on there, let's maybe count by, should we count by fives? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Yeah, that's probably not too bad. So if we count by fives, this would be 10, 20, 30, 40, 50, 60, 70. We don't have to go any further than that. So we've got 5 and 15 and 25 and 35 and 45 and 55 and 65. Okay, let's go ahead and put these down here. So 0, 0, right there. 1, 6, just a little bit above the 1. Okay, so not a very convenient point there, so we'll do that one. 2, 12. 2, 12 is about right there. 3, 18. 318, just a little bit less than 20, and 424, so a little less than 25. Now, this does look pretty good. To me, it looks like we've got a pretty good line going here. But let's check this one. Remember, if we were down here at 11 minutes, he would hit 66 hot dogs. So 11 minutes, let's go up and hit 66. So that would be about right there. And you'll notice that that lines up pretty well. So I'm actually going to grab my line tool and I'm actually going to stretch that line like this. Okay, looks like we're in good shape. So we've got these points. We've got that point right there. Straight line goes through the origin, lines up with the points. So we have shown this proportional relationship right here. I do want to just kind of make one extra point here. If we had m minutes, could you write down an expression that represents how many hot dogs he could get? So remember, what are we doing from here to here? How are we going from the number of minutes to the number of hot dogs? I want you to think about that. We'll come back to that in just a few minutes. So again, I'm going to shrink this down so we've still got some vision here of what's going on. It says pick any point from the graph or the table, write it below, and explain what it means in the context of the situation. So let's pick, let's just say this one right here. Let's pick 3, 18. Now, the 3 is in the minutes column and the 18 is a hot dog column. So here's what we'd write. In 3 minutes, he can eat 18 hot dogs. Okay, so that's what that means. All right, and again, you could pick any one of them if you wanted to pick 0, 0, 424. I suppose you could pick 1166 from that if you want. And then it says write an equation. And then it says be sure to write what each variable represents. Well, this is what we were getting at right here. How do we go from the number of minutes to the number of hot dogs? Well, if you'll notice this scaling factor, we're multiplying by 6 every time. So what we'd write down is we could write this down. If this is the number of minutes, then the number of hot dogs would be 6 times the number of minutes. So we're going to say this. I'm going to say H equals 6m. Or if you want, you could write Y equals 6x. And in this case, m equals minutes, h equals, I'm just going to write dogs here, okay? And on this one, x equals minutes, y equals dogs. So either one of those would be okay. I really think this is probably the best way to write it though, because again, it's nice when the variables remind us what we're looking for. Now it says what is the unit rate? Well, we figured out that unit rate toward the beginning, so the unit rate was 6 hot dogs per minute. And remember, when we say unit rate, we're talking about 1 minute. I'm not going to go ahead and write that, but keep that in mind. Then it says circle where the unit rate appears in the equation, the graph, and in the table. So let's go ahead and circle that. I'm going to highlight it here since we've got color. So we want it in the equation. So there it is right there. In the graph, right there, remember 1 comma whatever that number is, that's the unit rate, and then in the table, so right here. Now I'm going to come back here and I'm going to circle here, and circle here so everybody can tell what we were talking about. Question is this situation proportional? The answer to that is absolutely yes. And then it says use the table, the graph, or the equation to give at least 2 reasons why it is or is not proportional. Okay, so the graph's probably the easiest. So let's say goes through 0, 0, and straight line. That's pretty easy to tell. Another thing that we could say, let's see, same y over x ratio for every one of those. Ratio 6 over 1 for each one of them. We could also say same scale factor. It's almost the same as saying that it's got the same ratio, but just a little bit different take on that. Same scale factor from y to x or something like that. Any one of those would be fine, but I think these are probably the 2 best reasons there. And then it says if Joey were given 30 minutes, how many hot dogs could he eat? So if he were given 30 minutes, how many hot dogs could he eat? Well, 30 is a number of minutes. And we've got our equation up here, and all we have to do is say, okay, you tell me how many minutes he's going to eat, and I'll tell you how many hot dogs. So let's go ahead and give him 30 minutes. So if we multiply those together, we get 180. But remember, that represents H, so we would have to say 180 hot dogs. Now, you do have to get to a point where you wonder about the reliability of a mathematical model. What we've got right here, when we write down H equals 6m, that's a model that works for this situation right here. But would it get to a point where he can't eat anymore, or where he's not eating as fast and stuff like that? So yeah, this model probably would break down, and we might have some concerns about this. But given that question, that's a decent answer right there. He probably wouldn't last too long after eating that. Now, like any of these tests here toward the later part of the year, you should be prepared to answer some review questions from any of the previous units. So let's go ahead and take a look at these two problems. These are some equations. Just got to be a little bit careful as you're going through and doing these. But we kind of change our mindset from that whole argument of seeing what's proportional and not, to looking at these and saying, oh, okay, I remember how to do these. I've got to get the variable on the same side first. So I've got a choice between 1/4 x and 3/2 x. I'm going to move this one to the other side. So I'm going to subtract the 1/4 x. If I'm moving the x's over here, I'm going to go ahead and move that 5/6 at the same time. So when I move it to the other side, it becomes negative. Then I'm going to go ahead and, if you need to use a calculator, you can, but try not to. So I'm going to put these in 6, so I'm going to double that. So that's negative 14/6 minus 5/6, so I get negative 19/6 over on this side. I'm going to get a common denominator right here, so I'm going to double this so we have fourths. So this is going to be 6/4 x minus 1/4 x. So that's going to give us, let's see, what have we got there, 5/4 x. Looks pretty good. Now we're going to get rid of a fraction in front of the variable. So remember how we do that. We multiply by the reciprocal. So if we multiply this side by the reciprocal 4/5 and multiply this side by the reciprocal 4/5, then I can go through and I can do some cross cancellation. The 4's cancel and the 5's cancel, so that leaves an x over here. I can't cancel the 5 and the 19, but I can do some cancellation here. There's a 2 goes in here twice, 2 goes in here 3 times. So that means what's left on the top is a negative times a negative 19 times a 2, so that's going to be negative 38. And then I've got a 5 times a 3, so that's a 15. So there's our answer there. So we're in good shape on that one, so keep that one in mind. And then on this one, we've got some decimals. Now with decimals, you may need a calculator, so if you need one, go right ahead. On this one right here, hopefully you can think of what the answer would be. On this one, it's going to be negative 1.2a. If we multiply the 4 and the 5 together, they've got some decimals, but gosh, that's going to be, I think that's definitely going to be positive. I think that's going to be look at all those decimal places, 0.02. If you wanted to put it. I am going to double check on the calculator just to make sure. So let's see what we've got here. 0.4 times, times 0.05. Yep, 0.02. Okay, and I'm not going to have that 0 there. So this is 1.8. Isolate the variable terms, so we're going to subtract 0.02. Now if you're doing this by hand, this brings up a really good point. If you don't line these up correctly, you're going to get the answer wrong. A lot of people will do this. They'll do 1.8 minus 0.2 or 0.02, and they'll line up those, and then they'll get the wrong answer. So please don't do that. This is kind of like 180 minus 0.02. It's like $1.80 minus 2 cents. So we end up with 1.78 here. Check me on a calculator if you need to. And then negative 1.2a. And then we're just going to divide both sides by the negative 1.2. Cancel here. Now because this problem was written with decimals, it's okay if this turns out to be a decimal answer. But let's check and see if it does. Divided by negative 1.2. Yeah, so we get this big long repeating decimal. So a couple things that we could do here. We can write negative 1.483 repeated. Let's make sure I got that right. I did. Okay. We could write it like that, or most of the time we're going to end up rounding to the nearest hundredth, so 2 decimal places. So if I'm rounding to this place right here, I'm looking at the 3. The 3 is not enough to bump that up to a 9, so our choice really is between negative 1.48 and negative 1.49. This is not big enough to bump it up, so here's what we're going to do. We're just going to write down that the answer is negative 1.48. If you wanted to say that it's approximately that to indicate that you rounded or something like that, that would be okay. But let's go ahead and leave it like that. All right, if you need to do this several times, if you need to watch this, study it again, but good luck on your test.